All right, so I am recording. I'm gonna get the class started. Welcome to CISP 440. I recognize quite a few of you. Okay, some are new and I have not taught before. Somehow you escaped me in CISP 310. So anyway, this is CISP 440, and I'm going to rely on you to read the syllabus on your own so that we don't use up another hour just to talk about the syllabus. But please read it anyway, and if you have any questions about the syllabus, let me know and we can talk about those items if you have questions. Um, so we are going to start with the requisites of this class. There are three technically requisites. There's one prerequisite of Math 372. There's one prerequisite of CISP 360, which is irrelevant because of the co-requisite of CISP 430. So a co-requisite means you have to be either taking 430 this semester or you would have taken it already and passed with a letter grade of C or better from before. So that requirement by itself is guaranteeing that you would have passed CISP 360 with a C or better already. Okay? So do we have any questions about the requisites of this class? What you require? Okay? So if there are no questions about that, let me show you. Okay, let's see from your perspective. Okay. So there are these two activities. One is for the math prerequisite, and the other one is for the 430 co-requisite. This one, I think almost the entire class has met this requirement already, so I'm not too concerned about it. There might be like two people who have not had this cleared. So if you go to your grades and you see if you don't see 1/1 or 1/1 for this assignment, that means you have to do something about it. Okay. And the instructions of what you can or what you should do about it is already in the assignment itself. So check that. This one is a little bit different because most people in this class have not taken CISP 430 in a previous semester. I think like three people, have taken that class already, but the rest of the class have not. So that means, you need to provide some evidence that you are currently enrolled in CISP 430 in this semester. In eSurfaces, there are two screens that you can take a screenshot of. One is called View My Courses, I think, and then the other one would be your unofficial transcript. Now, on your unofficial transcript, it would have your grades from all your other classes, which I really do not care about. All I need is to know that you are currently enrolled in CISP 430. So you can basically block out all the irrelevant information if you do not want me to read your your grade from other classes, which I don't have time to do anyway. So, but if you want to hide that, it's perfectly okay. So, do we have any questions about the Math 372 prerequisite or the CISP 430 co-requisite? Yep. You probably want to take these two in the same semester or take it in sequence, which is 430 first and then 440. Well, it is enforced. So if you are not in CISP 430, see if you can get into one of the sections of the entire district. It doesn't have to be the ARC version. Hmm. Yep, you can do that too. If it is out of the district, then it's the same thing. You have to show me that you are taking that class right now, but you will also need to file a course equivalency petition so that I can evaluate whether the class that you're taking is truly equivalent to CISP 430. So that means you can go to Woodland, college, or you can go to one of the Bay Area city colleges. Typically, if it is within California and it's a community college, we all have equivalency pretty much established. So it should not be a big problem. Hmm? All right, so that's another thing you can do. If you want to get into CISP 430 and there's no vacancy, in Los Rios, but you find out that there's an online version of that course at Yuba City, okay, you can take that one too. That also works. Only one caution is if you're transferring, okay, different colleges, transfer differently to the different universities. So you want to make sure that this does not impact your eligibility to transfer to the university that you want to transfer to. So so that's something that you have to watch out for. Huh? Like like okay, so yes, that is correct. So this one, I think Berkeley is okay, but even within those Rios, the articulation can be different from one campus to another. Years ago, I have one student who, for whatever reason, took 440 from, I cannot remember, I think it was Folsom Lake, only to find out that the Folsom Lake version of 440 does not articulate with the university that this person wanted to transfer to. So that was probably unpleasant. All right. So any other questions about prerequisite or co-requisite requirements? There are no questions, then we're gonna proceed to so there's lecture recording. Okay, most of you already know that I have lecture recording on YouTube. My channel name is Some Profs. Okay, so if you follow this link, it will get you there. And I'm gonna add one more thing. So let me get out of the student view first. This is new for this class. I had something like this for my CISP 310 class from before, but it's new for this one. So I am going to add the external URL just as we speak. So I go to this one, and then I go to CISP 440TA. So I'm creating these bots using ChatGPT to potentially help you study the content for my classes. So it is still work in progress. So how well this works, I'm not 100% sure. So you guys can try it out and let me know. But it will have access to the reading material that you are supposed to read. So that means, once you read the material, you go like, I'm not really sure what this means. You can actually reference the equations or whatnot, in your interaction with the GPT TA. Um, as I said, I'm not really sure how well it works for this class, but I did try it out in CISP 300 and it seemed to work fairly well. All right, so unhide it so you can access it. There we go. So now we're gonna get started with the other links are actually hidden because it's not really that useful, once I evaluated that. All right, so we're gonna start with something that you are really familiar with or should be very, very familiar with, and those are the Boolean operators. So we'll start with the ones that you already know because of C and C++. We'll start with conjunction. So conjunction is really just a fancy word for and, A-N-D. In C++, it is known as ampersand ampersand. The mathematical notation is it looks like this. It is called the wedge. And there are multiple notations for conjunction. In this class, we are going to use the mathematical notation, or we can potentially also use the other formats. So this is the C++ notation. It is just ampersand ampersand. This is the mathematical notation, which looks like a TP or a wedge. This is the computer engineering notation. It looks like a multiplication. Okay. And because it looks like a multiplication, sometimes we don't even bother to use a dot in between. We just say xy to imply that it is x and y. So these are the various representations of conjunction that I might use in this class. Do we have any questions about those notations. Okay. So there are a lot of notations that we are going to use in this class. One thing that you might consider doing is to take notes and leave a certain section in your notes just for notations. So every time you encounter a new notation, you add to only that portion of your notes. So this way, all the notation definitions are in one single place. It makes it easier for you to look up and easier to review the notations because we are going to use a lot of notations in this class. We good with that concept? Okay. So section 3.2 talks about disjunction, and disjunction is just a fancy word for or, okay? And this is the truth table. I forgot to mention the truth table before. Does everybody know how to read a truth table like this? Okay, I have a whole lot of nods, but if you don't know how to read a truth table, that would be a good time to ask, okay, how do I read a truth table? But this is also an excellent opportunity to try out ChatGPT. So let me head over to ChatGPT and just ask, okay, show me the truth table of conjunction and explain how to read it. All right. So even names the module. This is the truth table and how to read it. X and Y are two Boolean variables. Each can be a 0, false, or 1, which is true. The expression X and Y is true if and only if both X and Y are true. In all other cases, it is false. So that's how we read the truth table. And this is an interpretation of and it also explains why this is important. Okay, you can predict outcome of logical, not so much predict, but you can figure out the outcome of logical expressions. You can build and debug logical conditions and so on. And it also even gives you some practice questions. So you can actually answer the question. The answer to 1 is 0. The answer to 2 is 0. The answer to 3 is 1. The answer to 4 is a 0. So it would actually check whether you got it or not. So that's what the TA does. Okay, the TA bot is going to do is it doesn't just give you the answer, it will give you some interactive activity just to double check that you got the concept. All right, so moving back. And by the way, the exams in this class are all in person. So ChatGPT is not going to be able to help you during the assessment. I just want to make that clear before people complain. It's like, but I have been relying on ChatGPT. I can't do a single thing without it. By the way, what do you guys think of vibe coding? I think it has its place for certain things. For instance, okay, if you are a professor teaching fashion, okay, and you go like, okay, but if I want to generate like models, they are always, in a different skin color than the one that I want, and there's not enough data to, kind of generate, realistic, skin color for certain people, then you can go ahead and go like, okay, I'm going to make my own, stable diffusion engine so that I can actually render, darker skin correctly. Well, vibe coding is an excellent application in this case because the Python code that is generated is nothing more than quote unquote glue in my view because it doesn't really contain logic. It imports a bunch of libraries, it opens a certain file with a certain name, read everything in, okay, you know, push it all through your PyTorch, train the neural net, export all the parameters of the neural net into another file with a certain name, and that's it. Okay, there's no logic in it, right? There are no loops, there are no recursion, nothing. So in that case, it's like, yeah, if it can save you a lot of time, just describe what you need to do, plug and play, I mean, just get the Python code, run it, and you're done. Okay, so in those cases, I can see the application of vibe coding. You don't need to spend like a whole year to learn Python and then learn about things that you're not going to use in that script. Generally speaking, on the other hand, I think Vibe coding is the first bubble related to AI to burst, and then it's going to cascade. But that's just me. All right, so next operator is called negation. It is the fancy word of not, which is represented by a single exclamation point in C++. So this is the truth table, and then the various representation is exclamation point. This is the mathematical notation of negation. In computer engineering, people typically use a bar on top of the variable to mean the negation of that. But in circuits, if you're designing a circuit or if you're reading the data sheet of a chip, then the negation is typically represented by a slash in front of the variable name. So these are the various representations of negation. I typically in this class, would use this notation if I need to do it really quickly, because this is actually not so easy to enter. Now, for those of you who want to learn, okay, so how do I enter this mathematical notation of negation? You can right click on it, go to Show Math As, and then go to Tech Commands. So this will tell you that \neg, N-E-G, and then the X is what you need to specify in order to specify this format. Is that okay? All right. So LaTeX format can be useful in your other math classes as well. So learning LaTeX, in the long run can be useful if you're planning to kind of lean more on the math side as opposed to the computer science side. Okay, all right. So are there any questions at this point? Yep, LaTeX, LATEX is pronounced as LaTeX because the LA is actually English because it's the initial of a person, but the so-called what you see as TEX is actually tau epsilon chi. It is Greek. That's why it's not pronounced latex. It is pronounced latex without the S sound. It's a typesetting language that had been used for science, math, and engineering paper publication for decades. So we don't use it for everything, but only for mathematical notations these days. You can use it, you don't have to use it. Yep. Yep. All right, so for notation purposes, I actually forgot to mention one thing that's kind of important because for disjunction, these are the alternatives. You can, the bar from C++, this is the mathematical notation. I typically want to use this one because it's the easiest to type on the keyboard. And then for multiplicate or for conjunction, sorry, for conjunction, I would use this particular notation because it's also easy to type. And then for negation, you can probably guess which one is the one that I want to use. Which one do you think is the easiest to type on the keyboard? Exclamation. Yep. The slash is not difficult to type, but it is confusing because it looks like division. Yeah. When you turn in homework or in an assessment in a test, you should be consistent. Yep. From 310, I think they're the same. Which one is different? Well, it's a different module. Yeah, the module is different compared to 310. All right, so that pretty much covers all the logical operators that you have learned already in CISP 360. So in this class, we also have, I think, two more, and one in particular is a little bit tricky, but it's used a lot throughout this semester. So we'll go through those. This one is not particularly useful, but I just want to introduce it because it is actually kind of cool. So this is called a NAND operator. It's usually represented by a up arrow like this. So this is X NAND X. So the definition of NAND is right here. So X NAND Y is the negation of X and Y because the word NAND, N-A-N-D, stands for negated AND. Okay, so you might think, but that's who cares about NAND? I mean, this is a really awkward thing and nobody uses it. Well, you are correct that no program code would use NAND as an operator because C++ does not support NAND as a single operator. However, NAND is the NAND gate, okay, is easy to implement using transistors. So as a result, the NAND gate is seen as what we call a universal operator, which means all other Boolean operators can be implemented by one or more NAND operators. And that's why it is of importance. Okay, so you might say, well, how important is this stuff here? Why is it of importance? It's because of FPGAs and EPLDs and those other devices. Of course, it's just a bunch of acronyms to you, and you go like, okay, well, what is an FPGA? And FPGA stands for, if you know the answer, you can also let the class know. Does anyone know what is FPGA? Yes, that is correct. It is field programmable gate array. Okay, so you go like, so what does it do? What does it do? Not quite the transistors. The smallest unit is a gate. Yep. It's you basically you can have a hardware implementation of custom logic in a device, and if you need to change the configuration, you don't need to solder anything. You don't need to desolder, you don't need to resolder, you just reprogram the FPGA. So the next question is, what can an FPGA possibly do that is of importance? Yes, you can, well, yes. So it is, you can describe the connectivity between the NAND gates in order to implement a custom, device. I can give you an example. Okay, so let's just say that you are manufacturing a cell phone, and you want your cell phone to have some capability of doing neural net related, computations. Okay, and you don't want to use the main processor to do it because it's time consuming, and you want the main processor to be doing other stuff. Okay, so in that case, you can program an FPGA as a co-processor to get some of the computational load off of the main processor. But let's just say that, okay, that's only for certain applications. Okay, with some other applications, I need to do, say, voice compression. Okay, and I don't want to use the main processor for voice compression. So you can reprogram the FPGA without having to reboot your phone so that when you are on a phone call or when you need voice compression, the co-processor is now reconfigured to do voice compression as opposed to neural network type of computation. It is field programmable, which means you don't need to ship your phone back, you don't need to flash anything. It can be done when the phone is up and running. All right. So it's kind of cool because if you think about drones, and other robotic devices, they cannot have like a specialized chip to do this and another specialized chip to do this and so on. So having an FPGA means now you can just reprogram that FPGA to do certain types of specialized operation, but you don't have it's not fixed. You can still change it on the go. So that from that perspective, NAND gate is important. All right, so moving on to implication. So this is starting to become super duper important because implication is an operator. Because most of the time we look at the word imply and go like, well, that's a verb, okay? Unlike and or not, okay, and those are not the verbs. imply is a verb, okay? So this is the reason why implication as an operator is a little bit more difficult to understand because implies is a verb. It is as if we are doing something, okay? But in the context as an operator, it is no different compared to conjunction or disjunction. You give it two inputs, it gives you the output. You give it two inputs, it gives you the output, and so on. So the truth table is really kind of the best way to look at implies as an operator because then you just go like, oh, okay, so whenever I see this operator, I just need to go through this table to figure out the value of the operator. Is that okay? All right. But for people who want to really kind of understand why the truth table is the way it is, then this example may be helpful. Okay, so I'm gonna have a statement that is kind of absurd. A blue cat is sick implies tomorrow is doomsday. Okay, it's totally random. Okay, that's a statement. Okay, as a statement, it is no different than a statement like Tack is a terrific professor, which is false. Okay, but the key here is it is false. I will give you another statement that is true. Iraj is a fantastic professor. It is true. So a statement is nothing more than something that can be either be true or false. Is that okay? Are we understanding what a statement means in this context? Okay, it is a statement. It is something that can either be true or false. So when I look at this statement here, a blue cat is sick implies tomorrow is doomsday. It is also just a statement, which also means that statement can be true or false. Is that okay? All right. So the only main difference between this statement being true or false versus, Iraj is a terrific professor, is there is a verb here describing something that seems to imply an action when there's no actual action here. So imagine this, okay? The other way to look at this is to say that you just paid me $100 and say, Tech, give me some words of wisdom, okay? And you hand me $100 each. Yeah, $50 because of inflation now is up to $100. Got to account for tariffs and all the other stuff. So for $100, you you got this statement here. These are my words of wisdom. Okay, blue cat is sick implies tomorrow is doomsday, and right away you go like, oh darn it, I want my $100 back. Well, if you can prove me wrong, if you can prove this statement is false, you can have your $100 back. Is that okay? So is that helping you to bridge the concept of, oh, this is really just a statement. It can be true, it can be false. If it's true, I just lost $100. I cannot get it back. On the other hand, if it is false, I can get my refund. Are we good? All right. So now the question is, when can you get your refund back? Are we good so far? So we're going to play out four scenarios. The first scenario is a blue cat is sick today, and then tomorrow is indeed doomsday. So now the question is tomorrow, even though it's doomsday, you still find time to come back to me and go like, Tack, can I get my money back? What do you think you can get your money back? Hmm? Nope, you cannot, because the statement is true. A blue cat is sick implies tomorrow is doomsday actually happens. Is that okay? Because a blue cat is indeed sick yesterday, and then today, being the tomorrow from yesterday, is indeed doomsday. So the implication is true. You cannot get your money back. Is that okay? Because the statement itself is true. All right. So if you're kind of getting hang up because of the word implies, there's another way to look at this. So when we say A implies B, we are also saying that A is a sufficient condition for B. Is that okay? So in this case, it means a blue cat is sick the day before is a sufficient condition for tomorrow or the following day to be doomsday, which means I don't care about whether a purple cat is also sick or not. Okay? As long as a blue cat is sick and this statement itself is true, then tomorrow is guaranteed a doomsday. Is that okay? So you can look at implication from the perspective of sufficient versus necessary. So there's sufficient condition, there's also necessary condition. If I specify necessary condition, it means, hey, if the necessary condition is not met, there's no way tomorrow is going to be doomsday. Okay, but in this case, implies means the first one is a sufficient condition. All right, so the second one, the second scenario is um, there's no blue cat is sick, and then the next day is not doomsday. So in that case, can you get your money back? You cannot get your money back because this statement here never says anything about what if a blue cat is not sick. It only tells you what should happen when a blue cat is sick, but it has no implication. It doesn't say anything about what if a blue cat is not sick. So that means if a blue cat is not sick, anything can happen tomorrow. You cannot get your money back. Are we good so far? All right. So that explains this one and also this one, because in both of these cases, a blue cat is not sick. So that means, this statement cannot say anything. Anything can happen tomorrow. You cannot get your money back. So the only time you can get your money back is a blue cat is sick and tomorrow is just same as usual. It's not doomsday. So in that case, you can get your money back because the statement here is really equivalent of saying a blue cat is sick is sufficient, is a sufficient condition for tomorrow to be a doomsday. So if yesterday you saw a blue cat being sick, but today everything is normal, it's not doomsday, that means my statement is false. You get your money back. Is that okay? So is this making the explanation of implication worse, or is it working out for you? Okay, if it's not working out, okay, the defect or the default way to understand implication is just to look at the truth table. Now, because you do not use implication as an operator in C++, this one will require some time to get used to, which also means it might be helpful for you to put this in your notebook just so that you can reference implication as an operator easily because it is used in a lot of places. And because this is new to you, you don't want to have to waste the time and also distract yourself. When I use implication as an operator, defining other, concepts in this class, you don't want to have to waste your time to go like, okay, but what does it mean, in terms of implication? How do the input or the left hand side and the right hand side relate to the output, which is the result of the operator? You don't want to waste your time to do it. So putting this in your notes can be very helpful with that. All right. And then the last one is called equivalence. And right away, we are reusing the definition of implication. So equivalent to, or being the same, is a double-sided arrow. So x being equivalent to y is exactly the same thing as x implies y and y implies x. Is that okay? That's the definition. So now the question is, if I didn't show you the truth table here, do you think you can work it out? You should be able to work it out. It might take you a little bit of time to do it because your implication is new to you, but this is really just using implication to define equivalent to. Okay, the truth table. Oh, oh, not x or y. Yep. So this is equivalent. Not x or y is exactly the same thing as x implies y. They are equivalent expressions. Can you look at equivalence? So every time you see equivalence, you just look at it this way. Yeah, you can do it that way. It's easy to remember with this one, because when the two sides of equivalent to are the same, then it gives you a true. When they are different, it gives you a false. So in many ways, it's kind of like binary comparison, okay? But this is a logical operator. Equivalent to is also known as if and only if. So when I say x is equivalent to y, it is also the same as saying x if and only if y. Yes. So in the previous example, x is called the precedent, and in this case, in this example, x is going to be a blue cat is sick. The y is called the consequent, which is what happens if the first one, if the precedent is true. So in that case, um, the consequent is going to be tomorrow is doomsday. So this is why. It it's literally x implies y, not if x is true. It is literally just x implies y. Sorry. So if the cat is sick, then you have these two rows in the truth table. So if tomorrow is not doomsday, then the implication itself is false. If tomorrow is actually doomsday, then the implication itself is true. What's the purpose of it? We'll see that in probably another 20 minutes or so. It is a very useful mechanism for, so by itself, it is not terribly useful, but it is used in the definition of a whole bunch of other stuff that we need to introduce in this class. Yep, later. Yep. And that's also why I want to emphasize note taking, because at the time when I mentioned this is important, put it in your notes. You may not know why it is important, so you kind of have to trust me when I said, hey, just put it in your notes. Use a single page in your notes for all the notations, just so that it's easy for you to look up the notations. All right, are we good so far? All right. So that's about it. Okay, equivalence is defined this way, and there are some question sets here, and this is generated by, I actually wrote a program to generate these. So you can see the question, and if you click on the little triangle, it will show you the answer of the entire truth table. So, yep, yes, yep, yep, that is correct. Yep. So with the previous one, if you use not y or not x or y, you can figure out the truth table as well. So that means, if x is false and y is false, not x is going to be true, y is going to be false. So you have true or false, which is true. What if x is false and y is true? Okay, the whole thing is going to be true because y is true to begin with. So we know the whole thing is going to be true. So you can work out the truth table by evaluating not x or y. Yeah. Say that one more time. That is correct. So when you have a or, so the only time you can also look at it as the only time the disjunction is false when both sides are false. So in this case, the only time when both sides are false is when x itself is true, but y is false. Then both sides of the disjunction is going to be false. So the disjunction is going to be, that's the only time it's going to be false. Yep. hmm Or that's the only time you get your fund, your refund. hmm All right. So are we good with the operators? So if I were you, because I'm more of a mechanical, kind of person, so I would just, look at the truth table and just remember the truth table. So I'm not overthinking, oh, what does it mean when we use the word implies? Nope, it's just an operator. So any questions about operators? No questions? So we're going to dive into some fairly, I wouldn't say abstract, but we'll dive into something that is a little bit more on the abstract side, and there are more symbols that you need to understand. So it's not about each symbol, it is how the symbols relate to each other. So so with this part, okay, there are a few links here. The deprecated ones are not wrong. Okay, they are just a little bit too verbose, which to some people is good. Okay, because some people like things to be explained in a longer way. So I would, if I were you, I would read the deprecated ones also, in addition to the one that is not deprecated. You can also see the not so deprecated one says, a more hair splitting way to define set notations. In other words, it is a very precise, it's a very concise and precise way to define those notations. So depending on, whether you like things to be concise and precise, or do you prefer things to be kind of explained out a little bit more or flashed out a little bit more, you can kind of decide which ones you want to read first and then which ones to read after that. Is that okay? All right. So as a class, I'll give you guys the opportunity to vote on which one should we read first. So should we read the new one, which is the hair splitting one, or the other ones? Hmm? Read the deprecated ones? Okay, so we'll start with the deprecated ones, which is they're a little bit more verbose, more verbose than I really want, but it's okay. So it is a lot more verbose because it will start with a description of what is a set and what are the elements. So it would describe the concept first, and then it will introduce the notation to say, oh, this thing here is a member of that particular set. So the first part here is really just uh, saying a few things about sets and elements. So a set is a container, and elements describe what a set contains. Kind of like a folder versus the stuff that you have in the folder. And you guys are going to say, but I can have a folder inside another folder. Well, guess what? You can have a set inside another set as well. So the folder being a set, files being individual elements, that analogy actually works to a fairly large extent. The second thing that is also a parallel between a set and elements versus folders and files is, can you have two files of exactly the same name in a folder? You cannot, okay? It's the same thing with a set. You cannot have two elements that are identical in a set. You can have one instance of that particular value, and that's it. Okay, you cannot have two instances of the same value in a set. Does everybody understand what I just said? Okay, all right. There's another thing about a set and its elements. A set is not ordered. In other words, You cannot say, oh, there's an intrinsic ordering of the items inside the set. There's no intrinsic ordering. So a set that contains the integers 1, 2, and 3, you can say it is a set of 1, 2, 3. You can say it's a set of 3, 2, 1. You can say it is a set of 1, 3, 2. You can say it's a set of 2, 1, 3, and so on. They are all considered to be equivalent because there's no intrinsic ordering between the items inside a set, unlike an array. Okay, so when you're dealing with an array in normal programming, the values inside an array, they can, first of all, you can have identical values. Two, an array that has zero, okay, I shouldn't use zero. Let's say 30. So an array that has element 0 being 30 and element 1 being 20 is different from an array that has element 0 being 20 and element 1 being 30. Is that okay? But a set has no intrinsic concept of ordering. So those are the special properties of a set. So now we are moving on to the notational part. So the notational part is basically saying if you have a set where it has a finite number of elements and you just want to show everybody all the elements in the set, this is the notation to use. So in this case, I'm basically saying T is a set where inside the set 12, 5, 2.2, 7, -1, and 10 are its elements. Is that okay? Does everybody understand this notation? So when you want to enumerate, which means you're listing all the elements inside a set, you have to use the braces to start and to end to enclose the actual list of elements. Is that okay? You have to use a brace. It cannot be brackets. It cannot be parentheses. It has to be braces. Okay, so when you turn in an answer, okay, let's say in a homework assignment or a test where you're supposed to use braces because you're trying to express elements in a set, but you accidentally use parentheses, I will take points off. Okay, that notation is significant. It is of importance. All right, so given that T is defined like this, then we can use this operator here to say, is something an element of a set or not? So this is called element of, okay, as an operator. You can also use, just simply in as the name of the operator. So that means 2.2 is an element of T, or 2.2 is in T, is a Boolean expression, which means it can be true or false. In this case, it is true because the way I define set T has 2.2 as its element. So that's why the expression of 2.2 is an element of T is true. On the other hand, 23 is an element of T is false as an expression because the way that I define T does not include 23 as a part of T, as an element of T. Is that okay? So this notation here is element of, and it returns a Boolean value. It's either true or false. Are we good so far? Yep. You can have that, but at this point, we don't have the necessary language to specify that. So we'll talk about it later. Well, at this point, this is just the really basic notations where we can define, oh, okay, these things for whatever strange reason are the elements of this particular set. So what you are talking about is can we have a more systematic way to say, oh, this is a set of even numbers, or this is a set of odd numbers, or this is a set of powers of two. Yep. So we'll talk about that later. Yep. All right. So food for thought is, why do we even need to understand the concept of a set in programming? Because after all, in CISP 360 and CISP 400, I don't think you guys had a use of the concept of a set. Vectors or arrays, yeah, those are pretty important. You guys talk about, sorting and searching and stuff like that, but not so much, a set, okay? So in reality, the concept of a set is actually really important in programming, even in really low level programming, even in terms of, the interface to the operating system to say, hey, if anything happens to these files that I'm watching, if there's another byte for me to read, or if it has room for another byte to output, let me know. Okay. So there's a system call like that. Okay. It's called a select call, where it will block a process until there's some movement on some of the files that you care about. So in that case, you have to specify a set of file descriptors when you say, hey, file operating system, this is the set of file descriptors that I'm interested in. If for reading, if there's another byte available to read, wake me up. Or in the case of writing, you're outputting to certain file descriptors. In that case, you're basically telling the operating system is like, oh, if any one of these files has vacancy for another byte, wake me up. So this way you can use a single thread in a program that can handle the input output of multiple files, quote unquote, simultaneously, which is a very useful technique in web serving and some of the other kind of low level networking techniques. So that's why it is important. So now we'll talk about the equivalency of sets. In other words, if I give you two sets, how can you know whether they are the same or not? Or how do we describe that they are the same or not? So right here, this is why it is not my preferred way of saying things, because right here, it is just a verbal description of what does it mean when I say set S and set T are the same. So the definition in this case is the two sets are considered to be the same when every element in S is also in T and every element in T is also in S. Whatever you can find in one, you can find it in the other one. Hmm? Doesn't matter what the order is. That is correct. Yep. So that's how we can define equivalency of sets. So now we move on to number 4. Number 4 is basically exploring the idea of, can we have a set that is an element of another set? The answer is yes. So if you look at all the, we'll skip some of the discussion here and jump all the way to the last one. So let's say, set X is defined to be a set, okay, because of the braces here. It has, well, let me ask you the first question first. How many elements does X have? 3 is correct. In other words, X has 3 elements. A is an element of X. B is an element of X. The set, the entire set that has 1, 2, 3 is one element of X. So how can we look at things like this? Remember the file analogy or the folder analogy? X is a folder that has 3 items in it. A is an individual file. B is an individual file, but it has a subfolder. Inside the subfolder, inside X has file 1, file 2, and file 3. So when you use the user interface in Windows to look into the folder that we call X, how many icons do you see? 3. Okay. So is that analogy working out okay? Okay. All right. Cool. So in this case, if X is defined like this, then this expression is true. This expression here is saying the set that contains elements 1, 2, and 3, the whole set is an element of X, is true. So set containment can nest. Are we okay with that concept? All right. Yes. So in this case, because X is defined to have elements A, B, and the set of 1, 2, 3. So now in return, when we use the element of operator, now we say the set of 1, 2, 3, the whole thing is an element of X. Yeah. Mhm. 2 is in X is false. That is correct. Because 2 is in an element of X. 2 is not directly an element of X. Very good. So this is the kind of thinking that I encourage all of you to do, is to say, okay, so how can I interpret these symbols? Okay, what are some of the tricky points of interpreting the symbols and also the definitions? So that's a good one. Yep. Yeah, you can. No, it's just a matter of establishing Y is a symbol representing the set of 1, 2, and 3 in it. Yep. So you can use Y. So if you define Y like that, then this is Y, right? Because the set of 1, 2, 3 is just Y, and this would also be just Y because the set of 1, 2, 3 is Y. But it doesn't illustrate the point of you have a set that is serving as an element of another set. All right. Cool. So section 5 here talks about the notation that we need in order to say, hey, this set has an infinite number of elements, but this is how we describe the membership inside the set. Yep. So this is serving as a single element from the perspective of X. I'm not sure what you mean by keep on going. Yes. Yep. Hmm? But it's no more complicated than just one level of nesting, because this is all based on, how do you say that one set is equivalent to another set? So as long as, in this case, 1, 2, 3, as long as 1, 2, 3 are the only three elements in the set, those it's the same as the set that has 1, 2, 3 in it. Yeah, ordering is not important. Yep. All right. So we are moving on to the notation to define a set with an infinite number of elements. So the first thing I need to make clear is this little funky looking z is the set of all integers. So do we have any questions about what it means to be the set of all integers? Hmm? Whole numbers. Well, I think whole numbers are only non-negative if you just use the word whole number or the phrase whole number. So this would include negative numbers as well. Yep. So is -5 in Z? Is 16 in Z? Is 2.5 in Z? Okay, so you guys are getting it. Cool. How about 0? 0 is in Z because 0 is an integer. The tricky part about 0 is it's neither positive nor negative. All right. So the problem with not having a formal notation and just go like, okay, I'll just give you some examples of what is in this particular set, is you really do not know what is before the -4 or what is after the 4. Okay. And also, by the way, you remember that there's no intrinsic ordering within the set, right? So I have no idea. Is this going to be -8 or is it -6? Yeah, they're both. possible according to the pattern, right? So you can never really tell. So we don't want to use something like this because it is vague. It doesn't really describe what qualifies to become a member of the set. So in the case of I want to express a set of even numbers, this is how I would express it. Okay, so from here all the way to here is the one way to express that E is the set of all even integers. Okay, so now you go like, but how do we read something like that? So the way to read it is E is a set where for each element x in the set, x has to be an element of z, which means it has to be an integer, and x mod 2 has to be 0. So that is how you read out the entire thing. Yep. You can contain the implication symbol here in certain contexts. But in this particular context, I need a conjunction because I need to make sure that x is first an integer because otherwise the mod operation doesn't make a whole lot of sense. Mhm. But there will be instances, hopefully today, where implication is actually used. So this is just an example. Okay, so E is just an example of, oh, if I want to express a set of all even numbers, this is how we do it. Okay, so the general format, okay, if you abstract it, the general format is something like this, where P is a predicate. So when we use the term predicate, P of x being a predicate simply means P of x is a function that returns a Boolean value. That's all it takes for P to become a quote unquote predicate is it returns a Boolean value. It returns either true or false. So that means, for something like this, okay, if E is defined like this, that means in order for something to be a member of E, that something, which we call X here, has to make the predicate P return true. Is that okay? Let me say that one more time. This definition here is saying E is a set in which every element X has to make P of X true. Is that okay? But that really is not the most precise way to describe it. The most precise way to describe it is E is a set where each, okay, I take it back. It's this one here. For every value X that is an element of E, okay, let me take it back. X is an element of E if and only if P of X is true. So that is the most precise way to describe the membership of E. Let me say that one more time. X is in E if and only if P of X is true. It is the if and only if or equivalence, which is kind of like the equality, but only for Boolean values. Mhm. It is exactly that thing. So this is why we define the operators first, which is also why I said, hey, you might want to put all the definitions of the operators on one little place so you can look it up. Mhm. This is abstracting because I don't really care what this P function is. This is really just saying this notation is the same as this notation. They mean exactly the same thing. That's all it is. Because most of the time we use this notation, the notation of E equals and then the braces and whatnot. The other one is a better way to look at it from the precision perspective, but from the notational perspective, it is a little bit more clumsy. So it's less used compared to the first one. All right. So are we doing okay so far with this portion? You cannot search for the two inside the set of 1, 2, 3. We don't have a vocabulary to ask whether 2 is somewhere within the nested structure of a set. There's no such operator. This is about notation, it's not about algorithm. So we don't have a notation to express the relationship between the 2 and the x over here. You can only, so membership is only at the top level of a set. You do not nest and look into each element inside a set and nest your search. You can, but there's no operator corresponding to that operation. Yep. So just because you don't have a notation for something does not mean it cannot be done, and vice versa. Okay, just because you can do something doesn't mean that it has a notation to go with it. So the way we are defining these operators typically is just is it true or not, right? So I can see what you guys are trying to say is, did, am I going to suffer because I have carrot somewhere in my lunch bag? So the answer is there's no direct operator that can tell you in a nested sense whether a carrot is somewhere within the hierarchy. So there's no such operator defined up to this point. It's only at the top level. Yep. Mhm. All right. So are we good with that? Okay. Now we move on. Okay. So now we move on to the concept of a set that has no elements. Well, okay, it sounds kind of strange, but it's not strange at all. Can you make a folder that has nothing in it? Can you have an empty folder? Yeah. Every folder starts off empty until you put something into it, right? So an empty set is exactly that. It is a set that has no elements. All right. So shall we move on to set operators? Okay, so these things, so what do we mean by a set operator? A set operator means it is an operator, typically has two sides. Both sides need to be sets. Okay, so that makes it a set operator. Now, what does a set operator returns? That depends on the operator that we are talking about. So we'll now take a look at intersection. So the intersection of A and B is a set where each element E has to meet this criteria. The criteria is E is in A and E is in B. So that's how we read this notation. Alternatively, you can also say E is in the intersection of A and B if and only if E is in A and E is in B. So these two notations are exactly the same, the top one being a little bit more popular, and then the second one is actually more precise, but less used by mathematicians. So it's really just a matter of style. I personally prefer the second representation because the first one yeah, can be a little bit confusing. Okay, there can be a confusion of so what about the intersection of A and B having elements or missing certain elements that meet the requirement. You cannot miss elements that meet the requirement. The second one make it very clear. Anything that can be found in A and B, You will find it in the intersection. Yep. So typically, we use uppercase for a set and then a lowercase for an element in the set. But it doesn't have to be that way. It's just a convention. Yeah, yeah. In my notes, I try to be consistent with that. Yep. All right. So I'll be good with intersections. Okay. And then okay, looking at the time, we only got 5 more minutes. So I'm going to switch back to the hairy one, the hair splitting one, which is also hairy. The reason why I want to get back to this one is because this one also has examples. So you actually get to see the examples of the intersection. So the intersection between a set that has ABC as elements and a set that has DAC as elements is a set that has C and A as its elements. This is the intersection. So this is why this particular um, version of the notes is also important. This is also the one that I use to I put the knowledge file of this file into ChatGPT. So if you are to ask ChatGPT and say, okay, give um, use an example to illustrate the concept of intersection, it actually knows how to do it because the notes is actually the basis of the custom GPT. So in this case, it explains what it is. Okay. So intersection means finding common elements in two sets, is asking what items are in both set A and set B. In logic term, if E is in A and E is in B, then E is in the intersection of A and B, and then gives you an example. So let's say we have two friends, Alice fruit favorite fruit is apple, banana, cherry, and Bob likes banana, date, and cherry. Now we want to know, which fruits are the overlap they both like. So we find the intersection, and it is banana and cherry because banana is found here and here, cherry is found here and also here. So I'm hoping that you guys are starting to see how the custom GPT can be helpful because it is using the material that you are supposed to be reading. Note the word of supposed to be. Um, and even it references back to the module number 2. So that kind of helps a little bit. It's like, where did we talk about this? It's in module 0279. Um, So, and it will leave you with an example. Try to find the intersection of X and Y in this case. So let's give it a try and see if ChatGPT is actually good enough to do this sort of thing. So what is the answer of X intersection Y? Equals to what? What is common between X and Y? I think we just got pencil, right? And I'm using LaTeX, which means I have to escape braces because otherwise braces have special meanings. Yay! But you can also see why this is helpful because if you have any doubt of I'm not really sure I'm getting this concept, you can actually ask ChatGPT in this custom GPT and go like, okay, I want some questions. Okay, I want to practice, and then you can give your answer to ChatGPT. Um, there's always a chance that it can grade you incorrectly. So if you think, I think the GPT is making a mistake, then bring it to my attention, okay, so that I can take a look and see whether the mistake is on your part or on the GPT's part. But I think over time, this is going to be a useful resource for you guys to kind of study. So as you read the material, You go like, I'm not really sure what this means. Ask the TA. Yes, it's not a whole lot. Nope, no, this is really kind of simple. The file that I upload to contain this kind of knowledge is about the same size as the file that you guys are supposed to read. So the human readable file is about the same size as the file that ChatGPT uses as quote unquote the knowledge base. Sorry? You're, well, we are inferior in many ways compared to machines. So who here can outrun your car? Exactly. So do you feel shameful that your car can go at 70 miles per hour on the highway and you cannot? There's no reason to. This is the whole reason we got cars, right? So GPTs is a tool, okay? It's going to be able to do certain things better than you can, and that's why we have them. But you also have to remember there are many things you can do that GPTs cannot do, okay? And I use this, in my CISP 300 class with you guys. The only thing I have to change is the timer, how much time is left. So in CISP 300, my opening is you got 4 years. The clock is ticking. You got 4 years to figure out what you can do that AI cannot do by the time you graduate. Because for in 4 years, Moore's law would have gone through two additional cycles already. Everything is four times as powerful by the time CISP 300 students graduate. With you guys, change the 4 years to two. Same question. Okay, you got 2 years to figure out what you can do that the AI tools cannot do by the time you graduate. You can. The only question is, what can you trust the answer, right? Yep. So there are many things. There are actually many things that GPTs cannot do, and I would advise you to look into the mechanism of GPTs first. Okay, how is it trained? How does the context window work? Okay, those are the two main things that you need to understand in order to go like, oh, no wonder it is so good at these things, but it totally sucks when it's trying to do the other thing. Hmm? It cannot apply rigid logic. At least with the earlier versions of GPT, it could not. Okay, I really haven't gone through a whole lot of tests with GPT-5, but you know, it may be able to do it. Okay, what I have discovered is this is also kind of interesting if you're interested in this sort of thing. What I found out is I'm suspecting GPT-5 internally would generate Python code for algorithmic or hard logic stuff. So that's why it always get those right when 4.0 cannot get those right. So I think it can differentiate between things that are kind of fuzzy, there's no hard right or hard wrong answer, and things that are totally algorithmic where you can just write a program to do the whole thing. Because there are certain times when the whole thing would just kind of bomb out, and then it would just display a Python script. It's like, what is a Python script doing in your answer? It's because when it was trying to run the Python script, something happened with probably the Docker, the container, and it goes like, and then instead of displaying the result of the Docker, it displayed the script itself. So I think that's what's going on, which addresses a really big concern from before, which is, oh, if I give it very definite instructions to do some, how closely can it follow the instructions? So I think the Python code actually addresses that particular thing. So anyway, um, I personally just like to take things apart to figure out how it works. Okay, I encourage you to do the same thing because this way you can tell your potential employer in 2 years, right? For you guys, it's about 2 years. And your employer will know that you know what you can do that the tool cannot do. And that is your value to the employer. All right. I'll see you guys on Wednesday. Have a nice evening. So there's nothing to be depressed about, regarding AI. I don't think vibe coding is going to sustain much longer. And eventually, companies will realize they need entry level employees because without entry level employees, they cannot have mid level employees. Without mid level employees, they cannot have high level or advanced employees to fix their problems, which will happen if they keep vibe coding. So the way I do it is I would the name of the video is going to have today's date on it. So today is 20250825, and then it will have the class name next to it too. I haven't uploaded yet because I'm still recording. Hmm? I record every day. Everything on the screen and my voice. It will be there. It will be on that channel. So there's no homework at this point because we have not covered